Welcome to the video. Today's topic of discussion is magnetic frustration. Yes, this is a most intriguing and fascinating topic in the field of physics, better to say in the field of quantum mechanics. So, topic is what? It is a magnetic frustration, means a frustration of magnets. Okay, you know the term frustration, but this term frustration here is related with magnets. How are they frustrated? Means how are the magnets frustrated? That is the topic of discussion in this video. So what happens in case of normal magnetic materials? You know that the tiny magnetic particles, means spins or the tiny dipole moments or the tiny magnetic moments, they always try to align themselves in an orderly state, and they can easily do this thing. Means they are found in an orderly state, means in an ordered state in any magnetic material. I am talking about those tiny magnetic moments or the spins of the particles by which the magnet is made. Now, certain situations are there where this alignment becomes not possible. This alignment becomes not possible. It becomes an impossible arrangement for that magnetic material. And this depends on the geometry of the material, or special cases may be there in which this may be found. Means they try hard, however they try hard, but the ordered states cannot be achieved by those magnetic particles, those tiny particles. So that is the problem. So in that case, what happens? There is a conflict of the state of spins. And this conflict of the state of spins is known as frustration. Frustration of the magnets. So the term magnetic frustration is being used here in this video. Magnetic frustration. Because there is a conflict. So to explain this thing, say, suppose you just imagine a scenario where three people are there. And they, what they will do? Those three people, they will hold hands. Means three people are arranged in a triangle and they will hold hands of others. But if everyone in that group of three people tries to hold hands of only one specific person, then what will happen? You can easily guess that is an impossible arrangement. Because in a triangle, say I am in a triangle. So at my right hand there will be one person and at my left hand there will be another person. Not the same person, because we are in a triangle. Arrangement is this. No way I'll get only one person. No way. Okay. So similar thing happens in case of special geometry. Geometry means here triangular lattice of spins. If geometry is such that triangular lattice of spins is there, then in that case there is an impossible arrangement. That means the spins will try hard to reach to an aligned state, means to reach to an ordered state, but they can't do their thing. So they will constantly fluctuate. This constant fluctuation gives rise to the term quantum liquids. Quantum liquids. Quantum liquids of spin. Because this behavior, the spins are in constant motion, and you know that when fluid flows, fluid is in constant motion. So here you can see in this case, when magnetic frustration is present, in this case spins are in constant motion. So there is a similarity between the fluid flow and this constant motion of spins. That's why this is called quantum liquid. Of course, quantum liquids of spins. Okay, quantum liquid of spins. One more thing is used here, that is called quantum chaos. Since they are constantly in motion or they are constantly fluctuating, means I am talking about the spins. So that means constantly there is a disturbance in the system. Constantly there is a disturbance present in the system. And chaos is being created that way. And that's why the term quantum chaos is also used in this case. If you talk about implications, yes, so many implications are there of this special phenomenon, magnetic frustration, such as quantum liquids. I have already mentioned that thing, quantum liquids. Then in case of a quantum computing, means quantum computers. Okay, in the development of quantum computers, this phenomenon is being explored by the scientists to use. Again, in the study of high temperature superconductors, this is required. Again, this special phenomenon can be used as the playground for studying or for understanding quantum mechanics in more detail. Yes, this can be used as a playground for studying quantum mechanics in detail. So many implications are there. Again, new materials can be developed. There is a chance, scientists are exploring this thing also. New materials can be used, can be created, can be developed by understanding this magnetic frustration in detail. And there is a chance that those materials, those special materials having special characters could be used in the development of quantum computers. So in near future, there is a chance that we could see the vast application of this special phenomenon, magnetic frustration. So many possibilities are there. And no doubt this is very interesting. And this state is called exotic state of matter. When this thing happens, when magnetic frustration happens, so in that case, that material, that phase of matter is known as the exotic state of matter. So to know, to understand, to explore quantum mechanics in detail, this phenomenon can be studied. Okay, and there is a technique, different techniques are there, such as a neutron scattering technique is there. That technique can be used to study this phenomenon, magnetic frustration in detail. Then muon spin spectroscopy, that is another technique. That technique can also be used to study this special phenomenon, not only special, very, very special phenomenon, okay, in detail. That means you can easily understand that, no doubt, this is an intriguing topic in the field of physics. No doubt, this is a fascinating topic in the field of physics. Magnetic frustration. Okay. So this was the topic of discussion in today's video. Anyway, so this was all about today's video. So this is the end of this video. Thank you for watching this video.